A consumer enters a retail store to get that perfectly fitting dress. She goes to her favorite section and looks through the defined size compartment, but did not find what she was supposed to find there. The XL bay has L-sized clothes. Talk about the nightmares of misplacement of items. This one thing is a major turnoff for any consumer and a major problem for the retail management. The idea behind our project is simple. Build a self-learning system which can identify changes to store layout and therefore work with the new layout design to determine possible misplacement of items inside the store. For this purpose, the project aims to utilize the information provided by video cameras located inside the store. Multiple images taken by these cameras need to be stitched together to create a 3D rendering of the store layout. This is then compared with earlier layout history to ascertain whether or not there has been rejig of the store. In case of a layout change, the new position of shelves and tables are determined. Additionally, the RFID antenna read all tagged clothes in their vicinity, and thereby the model needs to group or cluster these clothes by utilizing appropriate analytical algorithms. These groups then need to be paired with the identified shelves, racks. The overall solution has two modules. Ground Truth Module, to be carried out during the closing hours of the store in order to establish changes that have taken place compared to previous version of Ground Truth. Monitoring Module, to be carried out during the store operational hours. This will use the information from Ground Truth as a reference to generate the list report of items misplaced from their intended location inside the store. Team started with a physics-based model relying on the physics principles of RFID, utilizing radio signal strength indicator, phase, frequency, time of arrival of signal. After working on a bunch of features, RSSI distance was finalized as the feature to be used. However, further analysis revealed that physics-based model is not the ideal solution for this problem, arising from multiple interferences between tags and readers. Since the results of the physics-based model were not promising, the team started to investigate on machine learning-based approaches. Machine learning is a specialized subset of the broad area of artificial intelligence. It involves the construction of algorithms that can learn from training data and make predictions on test data. A machine learning algorithm is given a teaching set of data and asked to use that data to answer a question. For example, you might provide a computer a teaching set of photographs, some of which say, "This is a cat," and some of which say, "This is not a cat." Then you could show the computer a series of new photos and it should begin to identify which photos belong to cats and vice versa. What are features? Feature engineering by itself is a huge area of research and study. Features are variables that are fed as an input to the model. New features are created by modifying and transforming already existent variables. Used deep learning, artificial intelligence, to learn complex features. Features must be selected in such a way that features cover maximum information. Features are not redundant. What is ground truth? Ground truth refers to the real store layout with furniture that is used for training. The auto collection of ground truth data happens during the night while the store is closed. Example, distance between a furniture and an antenna times equals 19 feet. Given, this is the ground truth. Machine learning model predicts the new distance based on this. The image provides the actual location of furniture and antenna. This is the ground truth. Image acquisition. To work on machine learning methods, collection of data needs to be appropriate to establish the ground truth. Image acquisition focuses on getting the image from all the stereo pair rooftop cameras and placing it in a proper directory structure. The captured images are strategically placed in a layout according to the camera locations to create a composite layout of the entire store. This technique is called global projection, which ensures 100% coverage of the store. Objects like table, shelf, and racks are detected from stitched images using deep learning algorithms. Then, the captured images are compared to analyze and measure distances of each item with the help of motion analysis. The measured distance can be used to determine the actual distance of each object from the camera center. In the end, disparity maps or distance maps are plotted as an output of this analysis. After this, the centroid of each detected object was calculated, and this information was handed over to the data analytics team for further use. Meanwhile, the data analytics team was working on a set of tasks associated to grouping the EPC's electronic product codes that are placed together. As explained earlier, they use a machine learning-based technique called clustering for this purpose. RFID data from antenna reads and item attributes are used from RFID lookup database to cluster items, clothes, placed together in a store. The analytics team tried several clustering approaches, such as hierarchical, k-means, Markov, etc., and compared the results by measuring entropy. Based on the lowest entropy and distribution of EPCs in the cluster, hierarchical clustering was selected. However, the clustering results were not perfect, and accuracy measures did not match up to the expectations. There were a lot of overlap among the clusters, and in many cases, the cluster centroids were not close to the center of the clusters. It was necessary to map RFID cluster centroid to computer vision cluster centroids to meet the end objective of detecting misplaced items. Hence, the data analytics team adapted for a few deep learning-based approaches to improve the results further. Deep learning refers to artificial neural networks that are composed of multiple layers. It's a growing trend in ML due to some favorable results in applications where the target function is very complex and the data sets are large. Deep learning is being used across different fields: natural language processing, optical character recognition, speech recognition, artificial intelligence. In our case, deep learning was employed for the below objectives: deep learning-based regression to compute distance, deep learning-based classification for state change detection. The centroids, which indicate furniture locations, computed from RFID module, virtual clusters, mapped to CV module, real locations. 2. Deep learning is used for learning each cluster behavior based on multi-class classification. 3. This is used for state change detection of misplaced items by predicting the cluster number for data collected during the store's operational hours at regular time intervals. The final step of the project is to refine the clusters and perform a state change detection. The approach used for state change detection is called multi-class classification. Steps: the RFID data is grouped into bins based on 3 minutes interval duration. The training data is taken from 5 hours data, split into 3-minute intervals for each EPC. This consists of 25 bins, each for number of reads, frequency, phase, and RSSI. Each feature is given the label, which is the cluster number 1 to 20, to which that EPC is assigned. Once the model is trained, the test data consists of feature sets taken every 3 minutes during the time when the store is operational. The multi-class classification module predicts the cluster number for each test feature set for each EPC. This prediction is compared with the actual placement, and a mismatch indicates that the EPC is misplaced. State changes were detected successfully with more than 85% accuracy. A prototype or pilot of these use cases was simulated in the computer vision laboratory by replicating a small-scale retail store-like environment, and all the methodologies were tested successfully in the computer vision lab. Conclusion: consider this. A consumer enters a store to get a dress that fits perfectly. They go to their favorite section and look through the defined size compartment, and they find what they are supposed to find there. They are happy. Share their experience with friends and come back. Choose analytics to upgrade your consumer's experience.